Welcome to the Architecture of Verification, a strategic guide to the schools of unit testing. In this series, we'll explore how different testing philosophies help us build reliable, trustworthy software. Think of it as a blueprint, not just for writing tests, but for designing confidence into every step of development. Effective unit testing starts with one core idea: isolation. We test the smallest piece of code, alone, no database, no file system, no APIs, just the code, in a vacuum. This helps us catch bugs early. It gives us confidence to refactor safely, and it turns our tests into living documentation. Clear, reliable, focused. That's the power of isolation. What exactly is a unit? That question splits the world of unit testing into two major camps. Some say a unit is a single, isolated class. Others believe it's a cluster of classes working together to deliver one clear behavior. This choice shapes everything: how we isolate, what we test, and what our tests really prove. It's not just a technical detail. It's a philosophy. There are two major schools of thought in unit testing: the classical school and the London school. Classical says a unit is a behavior, even if it spans multiple classes. It focuses on state. Did the system end up in the right condition after the action? London says a unit is a single class. It focuses on interaction. Did the class send the right messages to its collaborators? To schools, to philosophies. Same goal: reliable software. To isolate our tests, we replace real dependencies with test doubles. There are three main types, each with a purpose. First, stubs. They return canned responses. We use them to feed data into the system and guide it down a specific path. Think of a stage actor. They say their lines, nothing more. Next, mocks. Mocks check behavior. They expect certain calls with specific arguments in a set order, like a detective watching for clues. And finally, fakes. Fakes are simplified versions of real systems. They work, but they cut corners. Like a flight simulator. It flies, but it's not a plane. Choosing the right double depends on your testing philosophy, and that choice shapes how you isolate. In the classical school, a unit isn't just one class. It's a group of classes working together to deliver a single behavior. Tests are isolated from other tests, but not always from internal collaborators. We use real objects for internal dependencies and reserve test doubles for shared or external systems like databases or APIs. The goal? Verify the final state. Did the system behave correctly, end to end? That's the heart of the classical approach. In the London school, a unit means one thing: a single class, isolated from everything else. Every collaborator, internal or external, is replaced with a mock. This forces loose coupling and drives design from the outside in. The goal isn't to check final state. It's to verify interactions. Did the class send the right messages? To the right collaborators? In the right way? That's the London mindset. Pure isolation. Precise behavior. Let's see the difference in action. To tests. Same goal. Different philosophies. On the left, classical. It uses real objects for internal collaborators and checks the final state. Did the account balance change? Did the transaction counter update? That's state verification. On the right, London. Every dependency is mocked. The focus is on behavior. Did the right methods get called? With the right arguments? That's interaction verification. Same scenario. Two ways to test. Each one reveals a different truth. Each testing philosophy brings its own strengths and its own challenges. Classical tests are resilient. They focus on real behavior, not just implementation details. They're intuitive when testing simple state changes, but they can be vague. A failure might point to a group of classes, not a single one, and setup can get complex. London tests are precise. They pinpoint failures to a single class. They encourage clean design and loose coupling, but they're brittle, tightly tied to implementation. Even small refactors can break them. And too many mocks? That can hurt readability. Choose wisely. Your testing style shapes your code. No matter which school you follow, great unit tests share one thing: structure. The arrange act assert pattern is the gold standard. First, arrange. Set up everything your test needs: objects, data, mocks, stubs, all the preconditions. Then, act. Call the method you're testing. Just one action. Clear and focused. Finally, assert. Check the result. Did the state change as expected? Or did the right interactions happen? One assert per test. That's the best practice. AAA keeps your tests readable, focused, maintainable. The goal of testing isn't a number, it's confidence. Chasing 100% code coverage can be misleading. It often leads to trivial tests. Tests that check simple getters or setters. They add maintenance, but don't catch real bugs. What matters is meaningful coverage. Tests that prove your system works, that give you confidence in correctness. Expert consensus? Aim for 75 to 85%. Enough to catch issues, without wasting effort. Because beyond a point, more coverage means less value. Focus on what matters. Confidence, not just coverage. Great tests don't just verify code. They make your workflow faster, cleaner, and more reliable. Here are 6 principles to follow. 1. Keep tests fast, simple, and independent. They should run quickly and never depend on each other. 2. Use descriptive names. A good test name tells the story, what's being tested, and what's expected. 3. Test one concept at a time. Each test should have one reason to fail. No more. 4. Test the public API, not the private details. That keeps your tests flexible and refactor-friendly. 5. Integrate tests into your CI pipeline. Run them automatically, every time the code changes. And 6. Handle all scenarios. Positive paths, negative inputs, edge cases. Cover the real world. Follow these blueprints, and your tests will do more than pass. They'll protect your code. So, which school is right for you? The answer isn't one size fits all. Use classical when you're testing core logic. Something self-contained. Something that should resist internal refactoring. Use London when you're testing a class with many dependencies. Something at the edge of your system, where design is driven from the outside in. And most teams? They go hybrid. They choose the style that fits the job. That's the real strategy. Know both schools. Use each one wisely. Modern testing is evolving, and these advanced techniques are raising the bar. First, property-based testing. Instead of checking specific inputs, we define rules. Rules that must hold true across thousands of auto-generated cases. If something breaks, we shrink it to find the simplest failing input. Next, mutation testing. It tests your tests by injecting small faults into your code. If your tests catch them, great. If not, your coverage might be lying. Mutation score tells the real story. And finally, AI-driven testing. Large language models now generate tests, analyze behavior, even create realistic mutants. Tools like Meta's Arc are scaling this across entire systems. These techniques aren't just smart, they're strategic. They help us test deeper and trust our software more. Testing isn't just about catching bugs. It's about building with confidence. Like a bridge, great software needs planning, structure, and a solid foundation. Unit testing is a design discipline, not just a checklist. When you understand the philosophies, state versus interaction, when you master isolation with test doubles, when you focus on clarity, not coverage, you're not just testing code, you're engineering trust. So build with confidence and let your tests carry the weight.